Hi, so in this video, we're going to be working with conditional statement. A conditional statement is the way that all of the theorems or postulate that we're going to be studying in geometry are written as, right? Before we go in on a conditional statement, I want to go over some definitions. The first one is a counterexample, right? And it's an example that shows that a conjecture is incorrect, right? So when we are proving that something is correct or true, we have to use variables and everything, but to prove that something is false, we can just use one example. For example, if the name of the month starts with the letter J, it is a summer month, right? As we know, January starts with J and is a winter month, right? So January is our counterexample because it's an example that is proving that this is false. Right? My next definition here is a conditional. A conditional statement is an if-then statement. So we're gonna have the if part, and then we're gonna have the then part. Right? This first part is called the hypothesis. Right? That part that is between the if and then, and whatever is after the then is the condition. Right? So definitions. Right? So hypothesis, conclusion, negation, right? This is important before we go, right? The negation is the opposite of the statement. An angle measures 47 degrees. An angle doesn't measure 47 degrees. Okay, it can also go the other way around, right? I can say that a shape is not a square, so my negation is going to be the shape it is a square, right? So the converse is telling that you're going to exchange the hypothesis with the conclusion. So we're changing hypothesis with the conclusion. The inverse, we're negating both the hypothesis and the conclusion. And the contrapositive, we are negating both hypothesis and conclusion of the converse. Okay, see this part here, right? So let me point here. I'm going to mark on blue the hypothesis, and in purple, I'm going to mark the conclusion. Okay, so purple and blue. So let me get the marker right here. Okay, so my hypothesis, again, my hypothesis is that part that is after the if. So in this statement, if a number is divisible by 2, then the number is even. So my hypothesis is that part that is after the if, and it's not including the if. So this is my hypothesis. Okay. My conclusion is everything that is after the then. So again, hypothesis, conclusion. This. Okay. Number 2 says if a triangle, if a triangle has 3 congruent angles, then the triangle is equilateral. Right? So again, my hypothesis is this part right here, the part that is just after the if, sorry, and just before the after. And my conclusion is everything that is after the then. That's it on this part. So it's pretty easy. This is gonna help me later on. Let's see what's happening here. Let me go. Okay, so now we're gonna write a conditional, right? Again, an if-then statement with this information that I have right here. So it says a regular pentagon has exactly 5 congruent sides. So we're going to start with the if part, right? If a pentagon is regular, then it has 5 congruent sides. That's it right there. Right, as you can see, I wrote the if and then. In this case, I changed a little bit, so it makes sense. That's it. The next one says all uranium is radioactive. So we can add a little bit more information. If is uranium, and then it is radioactive, and that's it. Right? Number 5, two complementary angles form a right angle. So if two angles are complementary, then they form a right angle. That's it. So in this one, I have look what is called a Venn diagram. That Venn is diagram is two circles or more, right? And they are showing a part where the outer part and the inner part where they have something in common, right? So, for example, in this case, Romance language, as you know, are Latin, Italian, Spanish, so on, right? So, inside of the Roman language, I have the Italians. So, I want to write a conditional from this one. So, I'm going to start with the inner part. So, if the language is Italian, then it is a Romance language. Right, I have this comma. Where's that supposed to go? Right, let me fix that comma right here. It goes right there. Perfect. Again, my inner part is my hypothesis. So if the figure is a square, then it is a set. Now, I want to determine if this statement is true or false. If it's false, we're going to find a counterexample. If the figure has four congruent angles, then the figure is a square. Oh, this actually is false. Why? Because a rectangle has four congruent angles. That's it, as you can see again, because I'm proving false just by stating that an example that proved that this is not true, right? If an angle is obtuse, then it measures 95 degrees. Again, we're assuming that the angle is obtuse, right? This is also false. I know that an angle that measures 95 degrees is obtuse, but not every obtuse angle measures 95 degrees. So let's say that the angle can measure, let's say, 101 degrees, and that's a counterexample. Okay. In this case, before we start this one, I'm going to go back to the definitions because I want to find what's a converse, inverse, and contrapositive. So let's go back to my. Okay. So if two angles are complementary, then their measures sum to 90 degrees. So my converse, let me write it. I'm gonna write it with different colors. Converse is gonna be blue, inverse is gonna be green, and contrapositive is gonna be. So we're changing again. This is the hypothesis. This is the hypothesis, and this is the conclusion. So I'm changing those two for the converse. So in this case, if the sum of the measures of two angles is 90, then the angles are complementary. Okay. Now the inverse, we're going to negate both of them. So if two angles are not complementary, then their don't sum to 90. Right? And my contrapositive, I'm actually on my contrapositive and actually negating this two right here. So if the sum of measures of two angles is not 90, then the angles are not complementary. Okay. Now I want to show which one is true and which one is not, right? So my conditional statement, it says if two angles are complementary, then their measure is sum to 90. That's true, right? As we know. If the sum of the measure of two angles is 90, then the angles are complementary. That's also true. If two angles are not complementary, then their measurements don't sum to 90. That's also true. And the last one, if the sum of the measure of two angles is not 90, then the angles are not complementary. That's also true. Okay. On this type of exercise, if the conditional is true, the contrapositive is going to be true. If the converse is true, the inverse is going to be true. And the other way around, if this one is false, that one is going to be false. Okay. Okay, so the next one, if a figure is a rectangle, then it has exactly four sides. Right? Let's start with the converse, right? So if, let me write it here, converse. If the figure has exactly four sides, then the figure is a rectangle. Right? And that one is false, right? Is false. Why? Because we can have a square counterexample, a square or a trapezoid. My inverse. Again, my inverse, I'm negating both parts. So if the figure is not a rectangle, then it doesn't have exactly four sides. This is also false. This is also false, right? And again, I can use exactly the same, right? Because the figure is not a rectangle, it could be a square. Okay, now my contrapositive, if a figure doesn't have exactly four sides, then figure is not a rectangle. And this one is true, right? Because if it doesn't have four sides, it cannot be a rectangle. And that's it for this lesson.